I've been looking for a replacement for my compressor for quite some time now. The one I have is 28 gallons and it runs out of air pretty quick. Also, when I was moving, it dumped over. Well, it was getting taken off the truck, and since the motor's on top, it broke the motor off of its casting, and so it vibrates real bad and leaks a little bit. Another reason for the upgrade is that I want to get back into automotive painting. Painting paint guns have kind of a high demand on the compressor. Also, it's a real pain when you're in the middle of a paint job and your compressor runs short of its duty cycle and you have to wait for it to recharge. A lot of times it could put you in a bad situation, or you wind up standing around in a respirator for several minutes listening to an ear-splitting compressor cycle. I did look at fixing my current compressor. One of the problems that I ran into is that the parts for this machine, which isn't even older than 15 years, they're out of production, and the existing quantity left that you can maybe find on eBay or whatever sell for way over $285, which is probably more than the entire unit's worth. So I started looking for a suitable upgrade. One of the ones that I came onto is the Quincy QT-5. I think it's about the right size that I need. This one was for sale on Amazon for $26.99, which is far out of my price range. If you guys have watched any of my other videos, you know that I'm not really scared of buying old industrial equipment and fixing it up. One of the good things about these is that they've been in production for absolute ever, and there are many fix-it manuals and replacement parts available. Quincy's been in the air compressor game since like the 20s. The QT5's been in service since like the 30s or 40s, and according to Quincy's information manual, they're rated for 80,000 hours of continuous use. That's somewhere around 40 years. So I passed over a bunch of these looking for them on Craigslist and elsewhere. Until I found this guy pretty close by that he basically was a realtor, and he had a building that was previously occupied by a dry cleaner. And so he was unloading both of these compressors for $350 under the assumption that they wouldn't work. In his defense, they were in really poor condition, and they'd been stored outside, and so they looked pretty bad. So I went ahead and bought both of them. I was going to try to fix one and sell the other one. The funniest part of the story, which I didn't capture on film, is me picking both of these up at the same time, getting them into the back of my truck without any kind of hoist, lifting, or lifting equipment. We just pushed them up with a come-along and laid them in there flat, and they fit nicely in the back of a 6-foot bed of a F-150. I knew that one of the compressor motors worked because he was able to start it while I was sitting there. He assumed that the other one was toast and that for whatever reason it didn't work. So the first thing I did when I got home was tore that motor and the pump off and tested it. And so I took it off and plugged it into the VFD that I have, and she started turning right away. Sounded pretty good, fairly quiet. So needless to say, I was super stoked. I just bought two Quincy QT-5 compressors that work for $350. That was a pretty good deal. So my next step was to basically tear everything apart and start stripping off all the paint, which was badly oxidized. In this picture, you could see that I chemically stripped the tank. Basically, it's a wipe-on, wipe-off kind of deal where you put the gel up on the affected paint, and then you scrape it off with a scraper a few minutes later, and it just kind of falls off. This kind of keeps a lot of the particulates out of the air that you would get from grinding to some degree, and also it's easy to kind of capture the wasted paint chips and throw them away. You have to use really good ventilation if you do that. That's why I pushed it outside, because people die all the time from being in enclosed spaces with that stripper. In the process of doing this, I was kind of worried about corrosion, some kind of pinhole or inclusion that had happened as a result of being stored outside. There was a lot of surface rust, and so it was hard to tell whether the tank was good to use or not. Because of this, I turned the compressor upside down and made sure that I inspected every single surface on it. In this process, I was not able to find any corrosion or scratches that I was not able to blend out with a wire brush. I wanted to make sure that there wasn't any serious corrosion on the inside of it. One safety concern with doing something like this is that the tank, if there's any weakened areas in it, it could burst during the inflation process. So I went ahead and boroscoped the tank. You could still see the stencil writing on the inside of it. There was some petroleum and some other debris at the bottom of this thing. I went ahead and used water to flush it out, but by and large it was fairly clean. I didn't see any evidence of any serious corrosion. Another option would be to hydrostatically test it. Basically what they do is they put it in they fill it full of water and put it inside of a pool and inflate it with water to, I think, whatever the rated PSI is, just to make sure it doesn't pop. It's a lot less dynamic if it does rupture with water than air. So I went ahead and primed the tank and some of the other components using a Sherwin-Williams industrial enamel. I've got several videos about this material system, and this is just something I had left, but you can see the results here. After stripping and repainting the tank, I went ahead and started looking at some of the other components. It was just a total tear down. You could see that the motor had some kind of wasp nest inside of it, which probably would have negatively impacted the ventilation for the motor. This next picture kind of shows the condition of the rotor and the stator. You can see everything's kind of rusty, but alright. I went ahead and kind of wire brushed the inside of this just to clean off the rust and debris. I stripped down the motor housing to bare metal just to get it ready for paint. I didn't paint any of the aluminum components, just the steel housing. I felt like the aluminum looked pretty good. This picture here shows the primed motor housing on the right hand side. Because of the amount of corrosion I found and just in general oxidation, I went ahead and took all the pressure relief valves and the pressure switch off and replaced them. I figured it was kind of one of the only safety elements on this device to keep it from blowing up. And I wanted to make sure that everything was new and fresh and able to perform its intended functions without any added risk of just the age and in general the condition. Then I moved on to the pump. The first step I wanted to do was to inspect the bearings, make sure everything was turning freely and in good shape. I wanted to flush out the housing and then replace the oil. I had no plans at the time to remove the pistons or the piston rings, but when I started inspecting things, I found this really thick petroleum sludge at the bottom of the housing. I wasn't able to fully evacuate it with a vacuum or with flushing. I was concerned that there may be grit or some kind of a medium inside of that was that could have caused wear of the pistons or the piston cylinders. So I took the piston housing off just so I can get a better look, and this is what I found. It was pretty gross. It's like a dead dinosaur deposit on the bottom of that housing there. So I went ahead and cleaned all that out. This picture shows kind of an inside view of that housing, what everything looks like taken apart. This shows the main pump bearing. It turned freely and it was in really good shape. So I continued the teardown process. Anytime you do like a project like this, you wind up with kind of a yard sale of parts all over the place. Here I'm just showing kind of an explosion of all the stuff that we pulled off of it. I did have some problems getting the air exit pipe off out of the casting. It's an aluminum casting and a steel pipe, so there's some corrosion. A tip that you can use to get something broken loose like this is if you use a torch around whatever substrate that the threaded part is installed into. What'll happen is it'll make that part enlarge, including the hole, and will reduce the amount of interference you have common to the threads in the threaded hole, and it helps to turn the part out easier. Also, if there's any grease or grime on the threads, it kind of helps to loosen all that up and make it fluid so that you can back the fastener out. It's important to add that you really want to concentrate the heat on the substrate, which has the female threaded part. You want that part to get bigger, but you don't want the threaded part that you're inserting or trying to take out. You don't want that to expand. So after we got everything tore down, inspected, and cleaned up, we went ahead and started the painting and priming process. You can see how clean these parts are now. This is what the main housing looks like after painting. I also spent some time painting the pulley and all the other components. I mixed in a little bit of black paint just for contrast. You could see that the interfaces where all the parts fit up, those do not get painted, so that you maintain a good seal after you put everything back together. At this stage, I started putting everything back together. I was in the process of getting the pistons back in, and I noticed that on the high pressure piston, some of the rings had kind of gotten brittle, and it looked like one part of one of the rings had chipped off, and then I damaged another one, put them back in. So I went ahead and ordered some new rings and some other, we'll call them maintenance items, so I could finish the build. After I got the new rings in the mail, I went ahead and installed them and got the pistons installed partially in the housing. I installed the piston arms on the pump shaft, and then lowered this housing on top of that and pushed the pins that connect the pistons to the arms in, and then kind of just wiggled everything until I got everything to sit down. Before continuing on with the build, I made sure that everything moved freely without much force, and that there was no noise or resistance. This is a picture of the valve assembly. It was a little dirty, so I took it apart, cleaned it with solvent, and reassembled it. I also wanted to mention that I ordered a new set of gaskets and seals. I wanted to make sure that I didn't have any leaks at the end of this build. This is what everything looks like put back together. Everything for the most part went pretty easy. I also installed this pressure gauge that I got from Quincy to replace the old one that I showed at the beginning of this. So now the only thing left to do is to run a quick test to make sure everything cycles right and that the pressure gauge worked fine. So you can see that everything's running great. The pressure switch cycled fine, no leaks, and so everything's working pretty good. I just pushed the compressor back in its final resting spot and put some pads underneath it to keep the vibration down, and did my shop routing. Anyway, I hope this video helps somebody else work their way through a project like this. Like I said, this old industrial equipment is, in a lot of cases, a lot better than commercially available stuff today if you bought it new. And so I'd encourage everybody to go out and figure out how this works and give it a shot, especially if you're on a budget, because like you see, sometimes you can pick up some really valuable stuff for almost nothing. I hope you enjoyed this video. If you got anything out of it, go ahead and hit like and subscribe. That helps the channel out, and I'll continue to put out similar content. Thank you.